Hello again. Welcome today in our lesson, which is a continuation from the previous lesson, where the previous lesson focused on the introduction of machine vision in agriculture. But this part of the lesson is now focusing on the basics of handling images, and we'll begin with image processing now. So this part will introduce you to it provides an introduction of the basics of handling and processing images, and it will show you some examples, and also it will introduce you to the basic tools and libraries that are used when you're handling images. So as a prerequisite, to follow through this tutorial, you need to have a Google Colab account or a Kaggle account. You may also use the Python and Jupyter notebooks that is installed on your machine. So you also need to have some basic knowledge of Python. I believe you had the Python class before. So you'll use the knowledge that you gained from that class and apply it here. So for our case, this tutorial is conducted by Google Colab, and I've used this because Google Colab, most of the time, it has a lot of libraries that are already pre-installed. So you just don't need to pip install every time. So to make it easier, it's easier to use Google Colab, or you can use Kaggle. And also you can use your Jupyter notebook. So as I go through the tutorials, some things which are different when you're using Colab or when you're using Jupyter notebook, I'll highlight that. So in case of installing, I'll show you the statements that are used to install certain libraries in Jupyter notebooks. So let's begin. If you're using now Google Colab, the first thing that you need to mount your Google Drive into the Colab by running the below piece of code. This is a standard piece of code. So when you from Google Colab, you'll import your drive, because all the data that you use if you want to save your images means that they're going to be saved in your Google Colab. So you need to import the drive. So from Google Colab, you need to import the Google Drive, and I've imported my drive already. My drive is already imported. So you see drive already mounted, and you can see from this part here, you say your driver is mounted, and unless you want to unmount it. And this is the drive, and you could see that this is the data that is in the drive. And yeah, so now that we have already mounted our drive, and this is because most of all the images or all the data you save in your drive. That's why you need to mount it. Now we'll start discussing the basic or the common libraries that are used when you handle images. So we'll begin with the Python imaging library. The Python imaging library provides the general image handling and lots of basic image operations. So if you want to do some image operations such as resizing or cropping or rotating, you can use the Python imaging library. And nowadays it's called Pillow. It was modified, now it's called Pillow. So if you're using Jupyter notebooks, you need to first install. It's a one-time installment. So you need to first install the library into your machine. So, and Pillow is the currently used library, which is derived from the Python imaging library. So for the first time usage, you need to install it, and then when you want to use it now, you need to import it. So if you're using Jupyter notebook, you should install it by using this statement pip install Pillow. After that, after successfully installing it on your machine, and it's when now you can use it to read it, to do basic image handling operations. So with Pillow, you can read images from most formats, different formats of images such as JPG or PNG or TIFF, or many forms of images, right? So you can read and write the most common ones. The most important module is the image module, and it's written with the capital IMG, image, the module, the image module is then imported and has, you need to, after installing your pillow, you need to import this image module that has a method for you to read and write images. So to read an image, you use a method that is called open. So which comes handy while you're reading an image in Pillow. So to read an image, you need to import it. Like I said, you import the necessary library or the necessary modules. For a case from Pillow, you need to import image. And this image has a method called open. That open method is used to read the image from your machine. So, and you can assign a variable for our case. For instance, in this example, we have assigned a variable called pil_im, and then you can say image open, and then you read the image from the directory, from the path. Now, you should be careful because if you're using Jupyter notebooks and your image, the image that you want to read is not on your current working directory. So you need to specify correctly the path of that image. But if you're working, if your code is, if your image is in the current working directory, you just need to specify the name of that image. I'll show you how to do it. So let's see, for example, we want to read an image that is in a Google Drive. So the first thing that you need to do is you need first from Pillow, provided that you have already installed the Pillow in your machine. So from Pillow, you need to import the image, the module, import the image module, import image. Then you have already, now this is, you have imported it. Then you come to, now you read the image from the directory that you're reading it. If it's not in your current working directory, you need to specify the whole path. So let me just assign, let's say call it image 1, and we're going to read it. Now you use the image, you write image, the module, and you need to write the method, which is the open method. You open your brackets and then you specify the path. Now, for instance, I want to read the image that is, let's say it's in my Colab notebook. Let's say, here are the images. So let me say I want to read this or this image. So with Colab, it's easy because you just need to come here, you copy the path, and then when you just paste it here, and now you have the correct path. Now, again, if you're working with notebooks, Jupyter notebooks, you need to specify the path where your image is found. If it's not on your current working directory, but if it's in your current working directory, you can just write, leave this out and just write your image name. So if it's in your current working directory, but if it's not, you just need to write the full image path and you can proceed. Now, I said the image is given in form of a matrix. So you need to know the size of the image. If you're working with images, it's very important to know the size of the images that you're working on. So I need to print the size of the image. Now with Pillow, you need to specify, I want to know the width and height of that image. And so the input image, which is image 1, say image 1 dot size. Then I'll use the print method to print the width as well as the height of the specified image. So let's run this. Now with Google Colab, you just need to run here. You control enter. So let's run this. So it gives us the image that is 8 by 8, meaning that it's the width of this image is 8. It has 8 pixels as the width, and height, it has 8 pixels as your height. So this is the size of that image. Now to get how many pixels are in this image, meaning that it's let's write another code. The total number of pixels. So if you want to comment in Colab, use the hash. So if I want to get the total number of pixels, this is a comment. Total number of pixels is just a multiplication, the length times width of the image. So it's 8 times 8. Or you can try it, because I specified the width, I would just take 8 times 8. So if I get that, meaning that this image has 64 pixels. If you remember, in the last session, I showed you that what we see versus how many, what the computer sees. So the computer sees a matrix of pixels, and for our case, in that image, if you draw the matrix, the horizontal and the vertical, the matrix coordinates, they'll give you, they have total of 64 pixels. So this is how you read your image when you're using the library Pillow. So make sure that you know that after installing it, successfully installing it on your machine, you need to import it. If you want to use it, you have to import it, and you import it from the, and after importing it, you import the most important module that is called image. And from the image, there's a method called open. This method open is the one that you use to read the image. So I want you to also try this given any image, and we'll give you exercise at the end of this class. So yeah, so we have read this one image, and we have seen how we can get the size of that image and the total number of pixels, which is 64. Let's get another example. For instance, I want to read another image, which is this image. This is the American, that's the name. So I can copy the path and then import the image module, and then use the method open, and I copy the whole path of that image that I want to read. And then like I said before, getting the size, you need to specify the width and the height. So let's run this. So we get that this image is bigger. It has 750 pixels. The size indicates that it has 7 pixels horizontally and 501 pixels vertically. So getting the total number is the same. You get the width times the height, you get the total number of pixels. Okay. And from there, okay, so we move to something else that is called, we want to know that, we said that an image is represented by a matrix, and it's given in form of f of x and y, like from the previous class. So the image, if you want to print the image now, and if you remember from your previous class, I mean from the Python class, you read about arrays, NumPy and pandas. So here it's really useful because an image is a matrix. So, and it has an array of numbers or array of pixels. So we really need to use the NumPy to read the array. So the first thing you need to do is you need to print the array of pixels. Like before, if you haven't imported your image module, you need to import it from the Pillow library. Then use the open method to read the image. So you read the image using the open method and specify the path where the image is. And you can print the size if you want, but we want to concentrate first on this part of the image pixel array. We want to print. So use the method asArray, np.asArray, to print this image that we have already read it here. So then after that, you can use the print to print this array. So let me run this. So if you run this, the first time I printed the 8 by 8 means that I printed the size from this one. This is the output when I'm printing the size, the width and height. And now I want to print the array. Like I said before, image is represented by an array of pixel elements or pixels. So you can see now, these are the picture elements in this image. And this whole part here represents one row. So you should be really careful. So in this case, there are 8 rows and 8 columns. So if you count this, there'll be 8. 1, 2, 3, 4, 5, 6, 7, 8. So meaning that there are 8 rows, 8 rows, 8 rows and 8 columns. So this part, from this part to this part gives the first row, this part to this part gives the second row, the third row, and so on. And then this one gives you the first column, the second column in that first row, the values of the third column, and so on. And this is a colored image. So it has 3 channels. As I said before, the colored image and the grayscale image. So it gives you the values of RGB, or red, green, and blue channels. So if you didn't get the first lesson, you should visit the first lesson to understand the difference between the colored images and the grayscale images and black and white images. So this is how you print you get to understand the array of your picture. So now let's move to another library, which is another common library, which is known as the OpenCV library. This OpenCV library is a open source computer vision library. And I said before, we gave an introduction what computer vision is, which is teaching a computer how to see like a human being. So when I look at an object, I can interpret an object that this is a table, this is a chair, or this is a leaf, or this is a fruit. So with computer vision, we are telling a computer how to recognize objects and further interpret it. So this library is a very simple to use library, and it's one of the most commonly used library. And we'll talk more about it and it's actually faster than the PIL library. So this is most commonly used. There are many libraries you can use, the sky image library, but for this lesson from now and another, when we're going further in image preprocessing, we'll use the OpenCV library. So if you're using Jupyter Notebook, again, you need to install it. It's a one-time installment. If you haven't installed it, you need to install it by using pip install opencv-python. And also, when you install this, because images are, like I said, they are matrix or they are arrays. So the NumPy array will be installed automatically. So if it's not installed, you need to install it again. So yeah. So now, like the pillow libraries that we did before, there's a specific module that the CV2 module that you can read the image. So we begin by reading the image by using the method imread method. The imread method is the one that is used to read the images. And like before, you need to read your images from the path where it is found, and we'll use the CV2 module. So to install it, and I want to show you, like for our case here, because it has already been installed, when I click pip install, it will tell me that the requirement has already been satisfied. So there's no need to install it again. So, okay, so now we start importing the necessary libraries. Now, if you're using Colab, it becomes a bit different. And okay, we'll talk about it when I want to show you, when we want to display the image. So you need to import the necessary modules, one being from OpenCV2, and then in Google Colab, you need to import this CV2, though, I am sure, if you want to display the image. And for the Jupyter Notebooks, you just don't need to write this. It will automatically, if you import CV2, you can display your image, and I'll show you how to do it in Jupyter Notebooks. So the first part is like the PO, you need to specify a variable that you want your image to be set, and then CV2 .imread, the method that is going to read the images, and then the path where you want to read your image. So this is the path where the image is. And if you're working again, if you're working with Jupyter Notebooks, meaning that you don't need to, if your current working directory is where your image is, you don't need to install you don't need to start installing you don't need to specify where you don't need to specify this whole path. You just write the name of your image. So you print the image. So print image.shape to get the size and the width of your image. And you could see there's an alternative where you can print like height, width, and the number of other colors. Let's run this and you see how to use it. So this image has the height and the width, and it's 3, meaning that it's a color image with 3 channels: red, green, and blue. And with OpenCV, it reads BGR, so it's BG and blue, green, and red. So, and there's a number of color channels and the height and width like I've seen before. So this is easy to just read one image and display that and read one image and get the size of that image. So for the case here, we write image.shape, but for pillow, you'd write image.size. So you should note that. But this will be focusing on OpenCV. You should know this for OpenCV. Okay. So now we have printed. We have seen these 2 libraries. We have seen how to import them and how to read an image when it's in a certain path in your drive or in your local machine. So now we want to view the image. So the first thing, to display an image in a window, we create. Now for Jupyter Notebooks, this will work when you display a graphic user interface, a window that will display the image. So the first parameter, if you use Jupyter Notebook, the first parameter you need to specify the name of the GUI, and then the second parameter, now that image that you read from your file. So we can show that the image in a pop-up. So it will pop up, and I want you, because I'm using Colab, you won't see that. But if you're using Jupyter Notebook, for instance, you're reading an image, it's called capture.png. Now you want to display it. So you need to cv2.imshow. This first argument here will be the name of the image, the name of the window, and the second argument, it's that image that you have read here. So then there's this thing, there's a method called wait key, because when you just display it, it will just display in a minute or second and then closes. So you need to specify this method that keeps the window open until you close it, and it will destroy using this method. So we'll do this in, let me see if we can do it in Jupyter Notebook. We can, so I want to show you now, I've switched to Jupyter. I want to show you how, and you are using Jupyter Notebooks, how you can read that. So I've already installed the OpenCV library in my Jupyter Notebook. So I'm just going to import the CV2 module. So import, like I said, import CV2. Then I'm going to specify, let's call it maybe image 2. I want to read an image, and so I'll use the cv2.imread method, the imread method to read the image. And this is what I wanted to show you, that if you're working on the, if your code is in the current working directory, you just need to specify the name of that image. So we want to read this image here. It's called banana image. So if I'm reading banana, Sorry. So if I want to read the banana image, so I'll just specify the name of the image, which is banana. That it's a PNG. The image format is PNG. Then I'm going to use the method I am sure, which is cv2 dot I am sure method. I'm sure method to show the banana image. But now the IM2 accepts two arguments. The first argument will be the name of that window. The first argument is the name of that window. Maybe we want to call it an image, maybe image 2 window or image 2. So this is the first argument, which is the name of that window, and I'll show you how it's going to display. And then now you want to display what image? We want to display this image which has been kept in this variable img2. So I write img2. Then because if I just use this, it is going to be continuous. It's just display, and it's within a second it will close. So what I'm going to do is I'm going to specify a wait key method. You can just use this method as cv2 dot wait key. It will wait for the wait cv2 dot wait key and any method. So it won't close it until you click close, and then after that use a method cv2 dot destroy, or destroy, which will destroy the windows that have popped up. So you use the method destroy all windows. So now we can run this, and you can see this is we specified the image is called image, it's called banana, and this is the image 2. The name of this window is image 2, and this wait key waits for us to close the window, so it will close the window. So this is how you read it in your Jupyter notebooks. I think most of you are using Jupyter notebooks, so this is how you do it in Jupyter notebooks. Okay. So another thing that you need to know is the one thing else. What else you're going to do is now let's come back to Google Colab. Okay, so with Google Colab now, you need to now the IMRead method. Now we are going to with Google Colab, you need to use cv2 underscore IMShow to display your image. The IMShow in cv2 is different from the one. So you need to do this in Google Colab. You need to import this, and when you're reading it, is image cv2. You use cv2 underscore image to display the image. So let's click that, and you can see this is our image. And one thing I want to show you is that the IMRead method can read a colored image. It can also read Grayscale image, and this is you need to specify the flag. The flag 1 represents a colored image, and then 0 represents a Grayscale image mode if you want to open your image as a Grayscale image, and then -1 this flag loads an image if it's a colored image as it is, and then it specifies the alpha channel. This is used mostly when you it handles the transparency, how you can adjust the image's opacity. We'll see this as you're working either in segmentation and want to segment the image from the background. So this is going to be important. So let's see if you want to already you have imported the cv2, you have imported the IMShow method. If you want to print it as a Grayscale image, so this is our image, you want to print it as a Grayscale image. So if I put 0, like I said, 0 is the flag that specifies the Grayscale. So if I so you can see that it has changed into a Grayscale image. So Now you can, okay, so now we have converted it. There's another method that can convert this. Instead of putting it here directly, you can use a method that so you can use the CV2.convert to gray and to specify which it accepts two arguments. The first argument being the image that you have already read here, and then use this CV2.color to BGR to gray, meaning that you're changing it from a colored image to a grayscale image. So if you display this image, it's the same image. So you can either specify here or just convert it by using color to BGR to gray. So I believe this is the first part that we have talked about two libraries, one of the two libraries that are common. And we have seen how you can install it if you're using Jupyter, how to do that in Jupyter Notebooks. And then how you're going to different methods that are used and modules that support the reading of images, and worked with Pillow and OpenCV, which is one of the most common and is actually faster than the Pillow library. And so installing it in your Jupyter Notebook and viewing the images using the I am show method. And then you can see how the difference between colored image, which has 3 channels, like I said, B for blue, green, and red. And then the grayscale image, which has 3 channels, which are, the 1 channel, which are shades of gray. And then next we'll talk about, now we have already read this image, then we'll talk about saving the image. But for this part, I wanted the first part to be reading a single image and converting it into grayscale image. So we could stop here for today and continue on another video. We'll talk about saving the images as well as reading now many images.